Okay, good evening, everyone, and welcome to another meetup of the Virtual Domain-Driven Design. For people watching or later watching, we'll also publish this as a podcast later on. So if you rather watch the podcast, go to virtualddd.com. And today will be about how future branching affects domain-driven design. And we've got Thierry de Pauw here with us. Hello, Thierry.
Hi there.
Can you introduce yourself?
Oh, damned. Uh, I'm Thierry. I'm based in Ghent, Belgium. Most of my time I spent as an engineering lead at the fintech startup Pax Familia. And on the side, I help organizations adopt continuous integration and continuous delivery. And last year I've organized GitCon, the continuous integration and testing unconference in Ghent, Belgium.
Cool. Yeah. So if everyone has questions on Zoom or on YouTube, let us know. We're going to have a conversation. I think our conversation kicked off 3-4 years ago at Pipeline.
Yeah.
I think we met there.
We met there, yeah, I remember.
Yeah, and we're both fans of trunk-based development, and we were talking, I think, a while ago. So I'm a DDDer. So first of all, let's talk about future branching. What is your perception or what is your take on what's future branching?
So I use Jazz's definition of feature branching. So it's a practice where people do not merge their work into master or into trunk, as long as the work, the feature they are working on is not yet done. And so when the feature is done, they merge back into mainline. But done means it's dev complete, but we still have lots of work to do before that feature gets into production. So you have to create a new build, you have to run all your automated tests, you have to perform your manual exploratory testing, you have to run your security tests, your performance tests, and then you can finally deploy into production. And then you have to run your smoke test, and then you can release your feature to your end users. So quite a lot of work is still need to happen after the feature is so-called done. Now, usually, so when we speak about feature branching, we really we mean like long-running branches that live for more than a day. Then we start speaking about feature branching.
I think that's already a good one, right? When I go to most companies, they say, yeah, we have short-lived branches of a week. Well, which is true because they came from 3 months, but you're saying a short-lived branch is less than a day, right? That's the definition I usually hear too.
Yeah, so that's what all XP practitioners use, because it's also related to what continuous integration is. You integrate at least once a day, and to be able to integrate, you need to merge at least once a day. And if everyone in the team integrates at least once a day, you get then multiple integrations per day for your whole team. And so you get faster feedback on whether the thing you are working on actually works or doesn't work.
Yeah. So it's a lot of discussion goes on about future branching, and you have a lot of people saying, future branching is a good thing, especially people going to the Git flow, I guess. Why do you think it's such a popular thing to do? What's your perception on why is it in my perception, such a popular thing to do a feature branch?
Because it's so easy to create branches with Git. It really started off with Git. There were some crazy companies doing really crazy branching with Subversion. I remember being in a training in a big organization explaining how to use Subversion, and I was like, wow, this is complicated. And then, well, with Git, it's so easy to create a branch that, well, and it seems like, yeah, it's a feature, so you have to use it. And then we also have GitHub that then introduced the pull requests that really then started to market the use of feature branches.
Yeah, which I can imagine is a good thing when you're running some open source project, right?
Indeed. So in the open source world, it has value because you have distributed teams, you have time zone problems, people are not working at the same time, and in addition, well, Git was really developed for developing the Linux kernel.
Yeah.
And it's really adapted to how Linus organized his team around this Linux kernel. So they have a system of lieutenants. So Linus works together with other people. He respects, or that he has. How do you say? Well, that he know that they will do the good thing, and so the work is distributed over those lieutenants, and every lieutenant can review the work of all the contributors, and they decide if something comes in and doesn't come in. So it makes sense for that use case.
Yeah. So for a context, when you're in an open source world or an open source type, even sometimes I hear Nicktoon has this social technical pattern where you use an open source team-like structure inside a company, right? And if you go for that, then Git merge request or pull requests. What is it again in GitHub? Merge request, I think.
No, it's pull request in GitHub.
Oh, and GitLab is merge request. I always get confused. So that it can be actually a good thing, right? Because you want to, well, have a sort of gatekeeping function on your open source for your team. So that's actually the background, I guess, that Linus created Git around, really for open source projects. But we started using it within software teams itself.
Yeah.
And what would be the problem? So I know a couple of problems. What do you think would be the problems using it inside your team? This merge request or this feature branching?
Well, first of all, it delays feedback. So as long as the branch is open and hasn't been merged back into mainline, well, you don't get any feedback because your continuous integration only starts the minute you integrate something into mainline. And so if your branch lives for a couple of hours or a couple of days, well, you are delaying your feedback for a couple of hours or a couple of days. And you just don't know, or you just don't get any information on whether you've done is actually valuable. So this is the biggest problem I see. Then we have several others. Well, you're hiding work for the rest of your team because, well, the things you are developing on your branch, while the rest of your team just don't see them. So they don't see how you are going to implement this. They don't see how this will impact them. It's only the minute that you integrate that they can start seeing the influence it has on their work. You're also introducing some sort of batching. So the longer your branch lives, well, the more work you are accumulating on that branch, and so the bigger your batch size becomes. And your batch size is the number of commits that exist since the creation of your branch. And well, from Little's law, we know that batch sizes has an impact on your throughput, and has also an impact on your inventory, because, well, all the work you are creating on those branches is just inventory creation, and this inventory is just money that is stuck into your system. And so, well, your company is just spending money and it doesn't get any revenue from this money because, well, all this work is just stuck in the branches and don't get into production. You don't get any feedback from it. And another thing I see, and it's more like from a cognitive perspective, that's how I feel it. So anytime I see branching strategies, I'm always like, well, I always felt stupid. I was like, whoa, this looks complicated. I never got my head around that. Probably one of the reasons I never really digged into branching, and I always worked on mainline because, well, you just have less version control system commands to remember and to execute. So for Git, you just need to pull your latest changes. You add your local changes, you commit, and you push, and you're done. Don't need to remember, oh, how do I need to create a branch? How do I merge that branch? How do I track a removed branch? All those sort of things.
Yeah, and I'm gonna make not a statement here, but I'm gonna say something. I once used Gitflow like 8 years ago or 7 years ago because I had a problem back there. So let's discuss that problem. My problem was I had back then, there was a roadmap. There was functionality that needs to be released in Q1, and there's functionality that needs to be released in Q2. So I found this golden thing called Gitflow, right? That gives me this branching strategy. And I still hear people talking about that, but I want to hear it from you. So how could I deal with, because some people still need to deal with that issue of having several features in several release states, right? They have this release dates open. So how would you deal with that without branching?
Well, first of all, there is a planning problem in there. And whenever I hear roadmap, I'm like, oh, wow. Oh, no. Most of the time, I don't know what I'm going to do in 1 week's time. How can you know that what you are going to do in a month, 3 months, 6 months, a year time? So, but that's aside. Well, the obvious thing to do is just using toggles, feature toggles. Whenever you start a new feature, well, just start it behind the toggle that is turned off by default. So feature is in your code base. It isn't enabled, and it gets into production, but it's not enabled in production. Your user doesn't see it, but you, in the meantime, can run all your automated tests against that feature. You have continuous integration of that turned off feature with all the other features, so you know how it will integrate with all the features. You don't have surprises at the last minute, and also your testers can do manual exploratory testing against that feature by turning on the toggle just for them.
Yeah, so is that something when you want to get more feedback, and is that a requirement? Future toggling?
It's not a requirement. In lots of cases, you can get away with just making sure that it's hidden. Like if you have backend services, backend API endpoints, as long as they are not used by a user interface or third-party service, wow, you don't need toggling. It's just there. You just have to make sure it's not discoverable. It's very easy. Same for user interfaces. If you're adding a new screen to your user interface, well, as long as you haven't wired that screen into the navigation of your user interface, well, it's hidden. Nobody can discover it. Yeah. But you know the URL, how to access that user interface. And so your testers can actually test the user interface while it is being developed. And once everyone thinks, well, it's okay, well, then you wire it into your UI navigation, and it's available.
Yeah, and I was thinking about that now while you say the availability, and you just put it in, and that's something I would use, right? I could write the whole API function without exposing the API. But the fun part is it reminds me of when I played World of Warcraft like 10, 15 years ago. And they actually do the same. It was always nice when a new release came, but not a full release, right? Not a full release, but let's say a minor release. But you could have there's some people, they went into the files and they were looking for changes, what's to come up, and they saw these names popping up, right? Oh, so we're getting a new this, or we're getting a new raid. It was already in the files, but not in the game itself. So that really reminds me of how probably games develop in the same way. They already built the functionality, but just didn't put it live yet, right? I think that's the mind switch people need to make. However, going back to your roadmap discussion, I've worked a lot with financials where they need to report certain stuff. So they have a roadmap of, well, Q3, and then it's an easy thing to say, right? We don't need continuous delivery because we know already what's to come in the next year. So why do we just do reporting each month? So why would we want this? What is their gain, right? They're just going live.
Yeah,
just playing a bit of devil's advocate here, right?
Yeah. Just a side note, I'm losing you sometimes, but it's okay now. Well, the advantage I see is you always have working software at any given moment in time. So at any given moment in time, your CEO or your CFO can walk in the room and just say, well, we need that feature now in production. Well, just can do that. You can say, yeah, well, no problem. We'll turn it on. It's available. Look, it's available now. Where many times people saying that, oh yeah, we don't need that. And then all of a sudden they need to release something like in a hurry. It still takes them a month to get it out.
Yeah.
Because, well, it's not always working.
Yeah.
For me, it's a very reassuring thing knowing that at any given moment in time, I can take the latest binary and I can just drop it into production, and it will work. It's lots less stress than the other situation.
Yeah, that's the other DDD where you're going into, right? Deadline-driven development style. And that always runs into stress. I've been into that situation myself. So we got a question. So let's say we have these classical teams, and Christina has this question. You wrote on Twitter about your work with several teams to move from disrupted integration to CI. How did you start with this change?
So yeah, it's probably about that one organization where. So I had this one organization where there were 15 teams working on a monolith. They had biannual releases. Well, in theory, they had quarterly releases, but well, because releasing was so painful, they just delayed releases. Obviously, yeah, when it's painful, you do it less often, is it? And so they ended up with releasing every 6 months. Now, nobody in that organization was really happy with that. Well, engineering wasn't really happy with that, and a lot of people thought they could get rid of this way of working. They wanted to go to fortnightly releases, so releasing every 2 weeks. And eventually they got budget to do that because they've tried to estimate what was the cost to get a release out. It seemed that the cost was somewhere 340 man days from code freeze to getting that release into production. And well, when management saw that, they were like, oh yeah, sure, here's the money. And what I did is based on what Steve Smith wrote in his book, Measuring Continuous Delivery. So I've tried out the improvement kata as a change management framework. So the improvement kata is something that Mike Rotter wrote about when he analyzed how Toyota worked. So the aim of the improvement kata is that you get large-scale organizational change and that you get everyone aligned. And so you start with defining a goal, a vision, something you want to achieve in the far, far future. And in this case, this was, well, we want to have fortnightly releases. So yeah, check, this is done. Okay, then we start analyzing what is the current situation. And for that, we used value stream mapping. And so we mapped their technology value stream. So everything that happens from committing into version control until getting the source code into production. And we did that in a collaborative way. So everyone involved in this release process was in the room. We were 20-something person, and we used Post-it notes. And so everyone started while putting the Post-it notes on the walls with the knowledge they had, and then someone else passed by and then changed the things. And so, yeah, well, all the knowledge that was sitting in all the individual heads, because, well, an organization is a complex organization, is a complex system. So no one really has the full information about what is happening in the organization. So everyone only has part of the information. So by doing this collaboratively, you integrate all the information that everyone has. And so we ended up with two technology value streams. So it seemed that they had, well, two ways of releasing. They had the feature value stream that took 6 months, and they had the fixed value stream that took them 2 weeks to get fixes into production. And there we had it. That was our solution. So we were like, well, look, this is your solution. We are going to focus on this fixed value stream, and we will make sure this thing is robust enough to get features out. And then we started defining a first improvement target that they wanted to achieve. And so this is something that you want to achieve during a first improvement iteration. That is something between 1 month or 1 week long. And for them, their first improvement target was like, well, let's make sure the stability of our deliveries is higher, because they had a very high failure rate of their tests. So tests were failing like 70% of the time, quite high. And so they wanted to achieve 30% failure rate in a month's time. We never really got that fixed, unfortunately. But they achieved the 2 weeks release cycle. But they never really achieved continuous integration. That was a big surprise for me.
And by continuous integration, you mean the definition of Martin Fowler, you commit to mainline branch at least 1 time a day.
Yeah, so there I take the threshold that Jess Humble defines for continuous integration is like, well, everyone commits at least once a day into mainline. Every commit triggers an automated build, an execution of the automated test, and whenever the build fails, it gets fixed within 10 minutes.
Yeah,
so they didn't integrate it or commit it at least once a day into mainline. They had branches that were jumping over the 2 weeks releases. And fixing a broken build took them several days. But they managed to release every 2 weeks. So they were satisfying business demand. So their domain experts were the first ones to ask for faster releases because they wanted to get faster feedback on the new features. So in that respect, so they achieved continuous integration because they could satisfy business demand, but they never really achieved continuous integration.
Yeah. So they did continuous delivery, sort of, but not continuous delivery. So your workshop, VSM, reminds me of the event flow, event storming Paul Reiner came up with. Did you also visualize the queues of each step?
Yeah, so I didn't really visualize the queues. I asked them, well, look, we have green post-it notes here. Try to estimate for every step in the value stream how much time it takes to execute that step. And then take the red post-it notes and try to estimate what the failure rate is of every step. And so we tried then to find what is the bottleneck by applying theory of constraints on the technology value stream. So theory of constraints comes from the book The Goal and comes from manufacturing. Now, it's very difficult to take over concepts from manufacturing into the software industry because, well, these are two different things. But the technology value stream is a very deterministic value stream and is very heterogeneous. So every step will, on every iteration, take the same amount of time, like it is the case in manufacturing. So we can apply this theory of constraints on the technology value stream. And so we try to find the bottleneck. And interestingly, well, the bottleneck wasn't really the manual testing, but was the execution of the automated tests. That also was a surprise.
Yeah.
Not really because the execution time was high, but because the failure rate was so high. So it adds lots of rework, and so because of rework, you have to re-execute. It adds up to your lead time, and so you end up with a quality bottleneck.
So what I hear you say is, so the question was, where do you start? I guess start by measuring.
Yeah, it starts by measuring and having a clear vision, and making sure that vision is understood by everyone, especially if you have more than one team. It's very important, and that it's a simple vision, not a 10-sentence vision, but really like 1 or 2 sentences. So you get everyone aligned.
And get these 4 key metrics out, right? The key continuous. I think Steve Smith described them in his book.
Yeah, so he uses the 4 metrics that the State of DevOps reports defines.
Yeah.
So it's 2 throughput measures and 2 stability measures. So the throughput measures is your lead time between committing into version control and getting that into production, and the frequency of deploying into production. And the stability metrics is it's your mean time to recover and the percentage of failures that you have. Now, I didn't really use those metrics because I thought it would be too much for that organization, so I only focused on throughput, so lead time, and on failure rate.
Yeah. And why was that? Because you think too much would be...
Too much to explain in too short amount of time. So we were speaking, so they contacted me in September, and they wanted to be ready for January of the next year. So we had less than 4 months to get there. When I started, I was like, yeah, no way you will get there. And they did.
So was this team using future toggles?
They didn't at that time. No. And I also get the exact same question, but yeah, how do we make sure that, how do we get away from those long running branches? Well, yeah, try feature toggles. It's only like a year later that they started investigating feature toggles.
Why would be that? Because someone has another question, right? How do we convince people to use feature toggles? So especially the enterprise software organization are slow to adapt. What's your take on that?
Yeah, so there are also a lot of scary stories about feature toggles, and that is what scares people. And I remember when I started speaking about the evilness of feature branching, it was the exact first reaction I always got, yeah, but feature toggles didn't work for us. We tried it and it didn't work. And yeah, well, there are pitfalls in it. So first of all, well, you have a maintainability issue. When you introduce toggles, you introduce branching logic. Branching logic makes it harder to understand your code, makes it harder to maintain your code. So you have to pay way more attention to readability of your code and to the design of your code. Another problem that happens quite a lot is that people don't manage their toggles. So toggles are on their own also an inventory, and you want to keep this inventory very, very small. So you want to keep your number of active toggles very limited. So it's like work in progress. You want to limit work in progress while you want to limit your feature toggles.
And that makes sense if you want to really get real feedback from users, right?
Exactly.
Because you want to toggle it off for the user to get feedback.
Yeah, so if you are piling up toggles, you are piling up features, and it means you have lots of features hidden. And it's also a form of inventory that you created. You invest quite a lot of time, quite a lot of money to create those features, but nobody are using those features. And so
it will just be a branch, but in the form of a feature.
Yeah.
So long-running feature toggles is also a thing here.
Yeah. Now, they can be useful for operational perspective. So sometimes you want to have long-running toggles, but just to allow your operators to turn off features when your application is in the high load. It's a thing Netflix does. Whenever they have problems, they make sure that the core functionality, streaming, works, and that all the side functionality is then, well, they start turning them off. And it's what they call gradual deterioration or graceful deterioration.
So now going back on the topic of domain-driven design, that really sounds like a design thing.
It's actually a design thing.
It's actually a behavior, right? So
yeah,
I can imagine these toggles aren't future toggles, but are just part of your design.
It's part of your design. It's a feature, and it's a feature for your ops people.
Yeah. Yeah. Well, not only the ops people. It's for your business, right? Keeping valuable business value more running, and lowering the amount of the rest. It sounds like a business requirement here for Netflix then.
Yeah, you could say that.
Yeah. So you would want to split that and put one part in your design. If you have operational toggles, it seems to me like it's a design issue and not a CD future toggle issue.
Yeah, I never looked at that way, but yeah, you're right. It's kind of it's you could say it's a business requirement.
Yeah. And going on to more on the topic of DDD, right? So one thing, what I see happening is this late feedback. And you were talking a bit about the shared mindset. So if everyone's on their isolated branches, I always say there's always design, and your design is also part of your feedback. Right?
Yeah.
So if you do work in feature branches, how are we still aligning on our design? Because I don't think we can actually, and I always use it in my talk, I don't think we can put design up front and then work and think that it will be implemented according to that design. Because during coding, you actually get feedback, right?
Indeed.
So that way it also slows down your design, I guess. Do you see this happening a lot? Where so I always use this picture of a stairs aligned to a building, but they're misaligned. So the stairs are like 1 meter to the left of where the doors are. Right? And then I say, well, this is misalignment on the hardware, and you see it, but this actually happens in your code. And then we just make a small wooden staircase next to it, because after 1 week of future branching, you don't want to realign, and you just take the quick route. Do you see this happening a lot, taking shortcuts and going towards, how do you say it, technical depth because of that?
I haven't seen that a lot. I remember that what I've seen is that during code reviews, designs were like, well, people saying, yeah, sorry, but that implementation, we cannot accept that. We have to review that we have to redo that design. And so 1 week of work was just going into the bin and had to be redone.
They did that. I usually see the sunk cost fallacy kicking in. Yeah, we didn't expect you to do it like this, but we have deadline, so let's twiddle it a bit, right? And let's take some technical depth here on the design.
Yeah, so now that was in a context where there were no deadlines. No deadlines in the sense of, it was less of a problem. But yeah, I've seen that. And
yeah, that's it's a waste. They throw it in the bin, right? Which sometimes for a design is a good thing to do, actually. So the outcome of the merge request is actually good, because you don't want the sunk cost fallacy, right? You just don't. We created it anyway, but the design fails. Let's continue on that. So that's actually a good thing, but it can be resolved just by having shorter feedback.
Exactly. So yeah, on the one hand, it's a failure. Failures are good because it gives us feedback. We learn from it. But, well, there's a difference between a failure after 1 week or failure after a couple of hours. It's just your throughput will just be higher with a failure after a couple of hours than with a failure after a week. And, well, to get back to design, I'm pretty sure that if you're working in your isolated branch, well, somehow this also manifests in how you communicate with the team. So probably you will not share, or I assume this will happen, that people working on their branch are not sharing how they are designing the feature with the rest of the team. And so there is no collaboration around that design. Collaboration is only happening the minute that the code review starts.
Yeah.
Now, interestingly, I once attended a presentation of someone from Github, how they work internally. And so Github uses feature branches internally, but they don't use Git flow. They use GitHub flow. So they don't have the long-running develop branch. They only have long-running master and then feature branches. Because they are working distributed, so there are no headquarters where all engineers are going. So it's just GitHub works in a distributed way. Because of that, whenever they start working on a feature, or whenever an engineer starts working on a feature, first thing they do is create an empty file, committed file, to allow them to open a pull request. And then they start documenting on that pull request, look, I intend to implement that feature this and this and this way. What do you think, dear team? And then they start a conversation around this between all the members of the team. Now, it's a distributed team. And that's how they reduce the feedback cycle. Now, I found that a quite interesting take.
Yeah, so we haven't discussed that part, right? So ideally, you want to sit behind one desk doing mob programming.
Ideally,
yeah, but I can imagine you don't want to do that all the time. So what would be the point of switching from mob to pairing, or well, I know Pivotal always pairs, but do you have any idea of what are the trade-offs between mobbing, pairing, and doing stuff, committing to mainline only
So I
without pairing?
I don't have experience with mobbing except at open space conferences where we just do some katas in mob style. But I do have experience with pairing. So I worked once for an organization where everyone was pairing full time. It's quite exhausting. Um, by times you're happy to do something alone. I give you that. But I felt it very reassuring to pair because I remember before that many times I was staring at the screen or like, shall I implement it like this or shall I design it like that? What would be the best way? And like the blank page syndrome of writers, well, exactly that thing. And there, once you pair, while you are continuously discussing, and well, I felt that very reassuring. And also, well, from a design perspective, we came to better designs.
What was it that you came to a better design by?
Because we had different insights, different backgrounds, different insights, different ways of viewing things. Now, in that organization, there was quite a lot of collaboration in the team. So we had many times also just design sessions at the whiteboard with multiple pairs. Like, look, we have this problem on this feature. What do you think? And I really like that. Now, interestingly, they did use Git flow.
Okay, so they were pairing on a branch or
On a feature branch, and they had a long-running develop branch.
So what was still their need of this? Well, for my sense, administrative task.
The chief architect.
Ah, okay. So it was a compliance thing, probably from.
Yeah, it was a compliance thing. Yeah, it's yeah.
Yeah.
And
but by doing that, they moved their feedback much more to the left, right? So
yes, because we still also did code reviews. So one pair implemented, and then another pair was going to code review, which I was like, yeah, why would we do that?
yeah, yeah. So that's the other discussion, right? Reviews, code reviews. So what I hear you saying is, why are we still doing code reviews if we do pairing?
Exactly.
I know that's a big discussion. So do you see any value out of reviews when you do pairing? I guess no, but why not? Because there's still another group that's not. We always talk about the shared mind state. So you're now a pair, but still in isolation again, with the other pair that's still in isolation.
Yeah, you can fix for that by switching pairs every 4 hours, and then you get the shared knowledge like for free. But it's exhausting switching all the time. It requires, and also you have to dig every time again into something new. But you get your shared knowledge when you do that. So in this regard, well, yeah, I don't really see value in doing still doing code reviews when you do pair programming. I used to be a very fervent advocate of code reviews. I think it dates back to Code Complete. I think it's there. I read something about, well, yeah, research has shown that when code is seen by multiple people, you get to better quality. And I also think it's Joel Spolsky said something similar. So yeah, I always advocated code reviews. Nowadays, I'm like, I see a lot of administration around code reviews, like it's compliance. But yeah, we do code reviews because, well, the industry does code reviews. And yeah, it's said to improve quality, but I dare to challenge that it doesn't really improve the quality. I think, well, there are other ways. Well, I think it's most of the time a waste of time, code reviews.
Yeah, we're not measuring there how much context switching waste there is, right? I hear you say about the context switch. When I'm really writing code and I need to do a merge request and I'm instantly out of the context, it takes me a while to get in there, and usually I'm exhausted anyway, so it won't probably be a good merge request sometimes. So I seldom see merge requests that really people take serious. People do, but usually they're like, yeah, I trust you, go on.
Yes, that's what I usually see. And then you have the pull requests that are touching 20 files or 50 files, and then you're like,
Yeah, too much.
how am I going to get through this as fast as possible?
Yeah, and I don't even know what's sometimes going on even after looking.
Yeah. So
Especially when it's a long feedback loop, right? Where they went to the right while I expect them to go to the left, and I'm more in disillusion of what's going on than why did someone pick this design? I have so many questions usually that probably when you getting back to DDD, when at some point you think your model might work, you go to sort of like design by coding, right? Either by doing TDD, because TDD is not about testing; it should actually be about design,
mhm.
and by doing TDD, but especially pairing and check as fast as possible if your design works. But I've never seen a design on paper of a complex. So let's talk about complex, right? DDD is most effective in complex for complexity, maybe complicated, but usually I never see a design up front that works. Eric Evans usually say your first design uh, won't be a good design, but you try to implement, try to make it rigid, try to feel it, go back to the drawing board, do it again, go back to the drawing board, and usually by the third design or third model, you're actually more having that. Well, this might work, right? And if you take a model and then let everyone go their own way or let pairs go their own way, the model will split because you get new insights during that coding by designing, right? Because you're so much into the unknown. And I think that's why future branches, while doing domain-driven design, won't work. Because especially in the early phases of you making a model, you need to have all these different insights from different people in your group to create a better model, and you will hit some roadblock during your coding. What you can do again, of course, is get the whole team together and discuss it again. However, that's then you snap people out of their context. So I believe more into first mobbing, maybe later pairing, etc.
Yeah. So with what you say, something popped in my mind. I never thought about it. It's like I have the feeling that feature branching is many times used in big design upfront context.
Yeah,
As you say,
it might be possible. Yeah,
as you say, yeah, your first model is never right. You need to feel it. You need to implement it. You need to try it, and then you get back. How can you possibly do that when you are branching?
yeah,
Well, you could do that in your isolated context, but then in the meantime, the rest of the world is moving forward, and you don't know that. And you don't know how your model will interact with the rest of the world.
yeah, yeah, or with your team. And I've seen this in mobile development where they have 3 or 4 teams using one repo and uses branches. Have you seen that before? And so they have like 3 to 4 teams. That's always the argument. And then we say, yeah, we need to use branches because we're with 4 teams, they were doing probably mobbing or pairing. Let's say they do everything perfect, but there's still 3 teams working on the same code base.
Yeah, and they call that team branches.
Yeah, probably.
Yeah,
But it's the same product. It might be a mobile app, for instance, right? It's
yes,
one
well,
app, but
I've seen that. Not one repo, one app, multiple teams. Each team gets a team branch, but they all work at the same cadence, on the same sprint cadence. So at the end of the sprint, all those team branches get merged into mainline, and then you have an explosion because obviously it doesn't integrate from the three teams, or even worse, small teams. I've also seen the team branch plus the feature branches. So every feature is branched off from the team branch, and then they do the integration inside the team on their team branch. And then at the end of the sprint, they do a rain dance, hoping that the integration of all the teams will work.
yeah. Yeah, and the thing I always, for me, when you need to use branching because you have that issue, for me, it's a design smell.
Yeah.
For me, it's a design smell that you cannot create proper boundaries, or that it is maybe part of one boundary, but your teams aren't effective
Yeah.
at development, maybe. But
So
also, yeah, there's also a language problem, because if you have 3 teams, they will use each 3 different languages. Well, we have a strategic pattern in DDD for it called shared kernel, right? Where you share the same model. However, that really takes a lot of dedication from the people, where you decide how the model changes. So your lead time will slow down because you need to take more decisions. You need to talk more together, make a decision, and implement it the same way. And yes, that requires code reviews, slows you down rather than speeds you up. So you can use the strategic shared kernel pattern, but I'm not a big fan of it, because yeah, it takes a lot of communication, and communication is expensive.
so the shared kernel is one model that is used by all teams. So it comes down to that.
By 2 or more teams,
Yeah.
that's a shared kernel. So it can be a shared library, but people can extend on that model for
Yeah.
their own team. But the core model, the shared kernel, is used by several teams.
Yeah.
Now, within DDD, we try to say the heuristic is one bounded context, one team. So you
Yeah.
won't want to have 2 teams on one bounded context, because their language will change. The
Mm-hmm.
language within the teams change, so it's really small, but you probably won't notice, but the design will fluctuate from each other. So there is a strategic pattern for that library, and you have an abstract core pattern that makes one model, but there are clear rules, and you need clear discipline within that teams to make decisions, right? Make rules, like we only change that part of the model when we all agree. And well, here you will slow down, because that sounds like the triarchy, like multiple people coming together in the tower, making that all decision, and it slows down. It's not continuous delivery anymore. It's discontinuous delivery, as Steve Smith called it. That's how I see it. But sometimes you need to use it. It's trade-offs. But yeah, rather
Yeah.
not.
It will depend on your context. I can imagine that not in all problem domains you will have clear bounded contexts that you can distribute among the teams. But yeah, well, as you say, the pattern of the team branch, or the anti-pattern of the team branch, has probably a lot to do with coupling. And it's one of the arguments I use why teams are probably using feature branches. It's because their code base is too coupled. Because there is no clear definition of bounded contexts. And so any change will ripple through the whole code base.
Yeah.
Makes it very hard.
Yeah. So I think we have there, I think it affects your design, right? Because your design is the mental state you want to share. So there's a question on the YouTube chat from Felixable. It said, someone told me recently, and we were discussing that for quality reasons, code review should be done even when working in pair, since the pair shares the same context and could make the same mistake.
Yeah. Fine.
Yeah. Yeah, my thing is switch pairs.
Yeah. Now, if you absolutely want to do code reviews, in my opinion, there are better ways to do it than using the pull request or the merge request model. You can also review code on mainline. You don't have to block the release for that. It's absolutely possible to have code, unreviewed code, released into production, and that is only reviewed when it's already in production. I've done that, quite successful with a quite novice team. It works very, very, very well. But we had team commitment that well, code reviews had to be picked up as high priority, and that whenever we found an issue, it got fixed with high priority. So that's the bad quality got removed from production.
Yeah. Cool. Yeah, so we have a few more questions too, and then I think we can wrap it up. But one is from Christina again. So, do you know how often during your last talk about the pairing with Gitflow, right? How often came the feature back after this pairing and after reviewing? Do you have any feeling or data on that part? So, you're shifting stuff left with the pairing. So, with a review will be better or worse?
So the problem was, so that was very interesting. They used Kanban in a quite bad way because there was piling up of work everywhere in the Kanban board, and one of the piles was code reviews. So nobody wanted to do code reviews because, yeah, obviously it's so fun to do. And so we ended up with a pile of code reviews. And at a certain point, we said, well, look, we can't continue like that. So we added a web limit on the code review, and the web was one. Only one code review at a time could wait for being reviewed. And if you follow Kanban, well, you have to first fix your web limit. So we had something like 20 code reviews waiting. And so, well, we sent the whole team into a room and we did mob code reviews. So the whole team was reviewing the whole code, and we just fixed immediately everything we found. And that worked amazingly, because from then on we started to do that more, doing code reviews with more than one people, and fixing the problems immediately. So we didn't have the ping pong anymore between.
Yeah,
I write some command, and then a half day later somebody else replies to the command, and then
it's actually putting the monkey on a different person's shoulder while you say, "Well, I see something here. Let's pair up and let's fix the problem, both of us." Right?
Now, not many features came back in that organization. Now, it was a strange organization. They were really very picky on the hiring, so they hired quite very, very good engineers, very skilled.
So that helped too.
So that helped. They had quite good design skills, but yeah, from a delivery perspective, yeah, it always struck me like, why are you using Gitflow?
Yeah, strange. Yeah, the chief ivory tower expert. Right?
Yeah, and I tried to suggest string-based development. I tried even to suggest it as an experiment on a project that was going to start with only 2 people working on it in pair, and still they started creating feature branches. And what's
Weird. Waste of your time. I always find Git flowing and branching a waste of my time to administrate it. It's just several steps more than I would want, right? So, from your experience, is there a correlation between team size, amount of Git repositories that it's divided into monorepo versus multiple, and the branching strategy they use? It's one of the final questions. Yeah.
I
So, a
would say
correlation between the team size, the amount of Git repositories, and monorepo versus multiple, and the branching strategy they use.
so. The craziest thing I've seen. So I don't have enough experience, or I haven't seen enough teams to see a correlation between team size, size of the organization, and branching strategy. But I did see crazy things, and we also and I also did crazy things in the past, not knowing better, like having trying to replicate branches over repositories. This is the most crazy thing you can do. So you have a change, you have a feature that is impacting multiple repositories.
Mm-hmm.
And so you end up creating feature branches in all those repositories. Once I've had the situation where I had to touch like 5 to 8 repositories, and I was going crazy.
So
That was
isn't that already a smell that there's a design flaw?
well, there is this, and there too, it comes from the open source world. This crazy idea that every single little thing needs its own repository.
Mm-hmm.
More and more feel for the monorepo.
What do you mean with single thing?
A library, a jar in the Java world, a gem in the Ruby world.
Yeah.
This idea also to create libraries, internal libraries. It's you have shared code that is shared amongst different applications.
Yeah.
Any change
for me, that's again it's a design smell, because if you have a feature touching several repositories, then for me it's weird that it's touching several. Weird, it's not the thing, but then you have a lot of things you need to, and it's the same with microservices, right? A lot of things that needs to change.
Yeah.
And if that's your feature changing a lot of things, then you might, especially over several teams, and you might have a Conway's misalignment there, or some weird thing going on there. So for me, it's usually also a code smell that one feature touches several.
It's a code smell that dates back from the idea don't repeat yourself. And people started to implement that really very precisely, like, oh yeah, I may not have duplication of code. So the problem is not duplication of code. The problem is duplication of concepts, or of the duplication of models.
That's what we
code
say
is perfectly acceptable.
Maybe not within a bounded context.
Not
we usually say, but over bounded context, it's perfectly fine.
It's
sometimes, but it's trade-off. It's a trade-off, and you need to be aware of it. Yeah. So for me, that's again, it's people doing feature branches or needed feature branching, and I always ask the question, why can't you do trunk-based development? And then they gave me all these reasons that are usually design smells.
Yeah, exactly.
And that's how feature branching for me affects domain-driven design, or design as a whole. But let's just not call it domain-driven design, but software design.
Yeah. So it's usually there is a design problem. It's the coupling problem. Another problem is also, but that's also a design problem, is not having the skills to work in small increments. But to be able to work in small increments, you need a proper design. And so you need a decoupled code base. Otherwise, you cannot work in small increments. Usually there is also a problem with your build lead time. It's just taking too long to build your application and to run all the tests. And well, if it takes you an hour to build your application, well, you can only commit every hour.
Yeah.
And usually, well, these are smells, performance smells. and usually it also goes back to a design problem.
Yeah, yeah, I think we agree on that part, and I think that's how feature branching can affect domain-driven design, right? So if the need for feature branching is like, is there something? So if you need one, there's probably a code smell or a design smell somewhere, and B is be mindful of the cognitive. Um, the misalignment when you go into feature branching, right? Your misalignment on your models, especially when your model is not rigid enough. It's worse to just go your way and then go into misalignment. So to finish off, I have one question. Let's say people are listening to this. Let's say people are listening and they are doing feature branching at the moment, and they recognize this stuff and they want, I want to change something. What can they do tomorrow to start changing? So they see the code smells or the design smells, they see, well, but now they want to change. So what's the first thing tomorrow, what they can start off with or start planning with or start doing? What would be your key advice? Do this tomorrow to start your journey towards less feature branching.
So I would tend to follow Paul Hammond. Paul Hammond is Mr. Trunk-based development.
Yeah, he has the trunkbaseddevelopment.com site, right?
Yeah, and he also made trunk-based development known by the world. Well, try to shorten the lifetime of your branch. If it's living longer than a day, well, try to get it to a day. Once you get there, well, try to get it to half a day. Try to get it to a couple of hours. Look at what is keeping you from shortening this lifetime. What is the biggest obstacle in there? Is it the code problem? Well, try to start to fix the little things, like Ken Beck says. Whenever you see a problem, just fix it immediately and make it better. But well, look at the obstacles that are preventing you to shorten the lifetime. And well, you could also there use the improvement getter, like create a vision. We want trunk-based development, and then look at what is your current situation and what is keeping you from not doing it.
Yeah.
And then define improvement targets, like, well, what experiment can we try in our context? Because I cannot say, well, start with this experiment or this experiment, because I don't have the context where people are in. There is no one roadmap to get there. There is no one maturity model to get there.
Yeah, that's a whole different discussion. The
Yeah.
maturity model. Yeah.
That's why I like the improvement getter, because it takes the context of the organization.
Yeah, it's a context aware, context specific. Great. Well, thank you very much for joining in this meetup. I really enjoyed it. I hope you did. Great. And for all of you here, thank you all for listening or watching. And just so you know, within a month, DDD Europe will start. We're going to share some codes that you can get some discounts on. We'll be there with Virtual DDD. It will be announced, and we're going to do some retrospective about the last year. What do you want more out of the Virtual DDD meetup? Do you have nice topics? Do you have book recommendation? Or do you have other features you want to discuss with us? That's it. The next meetup will be next Thursday. We're going to talk about DDD, BDD, and UX. What's the correlation between the two? What can we learn? Or between the two, between the three? What can we learn from all three? So hope you'll tune in back then and have a pleasant night. Bye-bye. Thank you very much.